All right, so this week you had a phylogeny activity, and some of you posted up your flip grids looking at your cookies, and I have provided feedback, so you can take a look and see what I've said about it. For those of you who have not, I'm going to very quickly demonstrate how I'd put the cookies together potentially, and then I'm going to go into a little bit more detail on how I'd run this phylogeny activity, really the end of the week product. And I know it's a little complicated. Normally I'd be with you and we'd be kind of going back and forth. So first thing with the cookies, if you're doing a phylogeny activity, you have to figure out what your ancestor is. I made it a little easier by just telling you that this is the ancestor here, but you could have made one up if you wanted to. And this cookie is rectangular. Notice that there's no chocolate, it's just, a wafer. And so from this one cookie, there might be an evolutionary event, I'm thinking, that may have caused you to have the same shape but a different color, and it may be some kind of environmental pressure caused the formation of this chocolate, right? So I would draw a line showing this connection, right? There's my line, and a speciation event happened right here. You don't need to show that. And so I have these two cookies. And then next, from this chocolate cookie here, maybe I have it changed shape. So it's still a wafer with chocolate, except now it's circular. This one here, as a wafer, it has no chocolate. So maybe this is a line that kept on going. Over here, this might have easily changed into this, or I might suggest that it kept the rectangular shape, but it ended up getting chocolate on either end. Right? So that could be another speciation event occurring. And this one might have just kept on continuing. And then finally, as my last cookie here, I might put it like this. I'm unlikely to put it here. It doesn't make a lot of sense. I was going to go from rectangular to circle. It could, because it went from rectangular to circle, but I think it makes more sense over here. I think that the chocolate went from being a wafer and chocolate layer to the chocolate kind of striping it for whatever reason. The environment caused a selection pressure that forced this to occur. Right? There are many different answers. Just because I chose this one doesn't mean the one that you want to choose is incorrect. Normally if we did this in class, there would have been 10, 15 different groups. There would have been 10, 15 different answers. Okay, so I just drew those lines there because it is possible that these cookies here, it's possible that they didn't change. So at the very end of this, maybe you don't have to show that, but maybe at the end of this wafer is still existing here, and this wafer with the chocolate's existing here, and then this one's existing here. Like there's a lot of different possibilities that could occur. So that's how I could do the cookies. So hopefully you had a chance to try that. I see that 5 of you did, and I'll give you some responses momentarily. In the next activity, the phylogeny activity at the end here, right? This is yellow. So this is what you need to do if you want to complete your work with few gaps. You had a choice of completing part 1, which I said was completely optional, part 2, which was completely optional. Many of you are going to probably skip right to the part where you're actually creating the phylogenetic tree. So I haven't grabbed all the images here. So you have all the images at the bottom of your sheet, right? I've only grabbed a small sampling to demonstrate what I might do. So what you want to first do is you want to pick something that's super simple, something that doesn't have a lot of complexity, something that could probably evolve relatively easily into another shape, right? So I might choose this knife, it's not a knife. I might choose this nail. Because when you look at this nail here, I'm just going to make it bigger so you can see. It's simple. There's no grooves, there's a little simple head. There's that piece of paper that tells you it's pretty small. So this might be my ancestral organism. And then from the organisms I have in my list, I have to figure out what this may have evolved into, what speciation event might have occurred. So many of you, when you're planning this, you probably want to look at these and you want to see what's similar. So when I take a look at this particular whisk attachment, and I take a look at this whisk here, I'll notice that the two of them are very similar. So in my opinion, they're probably going to be in a similar clade with each other. Right? So I'm going to group those two together. And then I see that this thing here has 2 parts to it. the two little prongs, but it's also got plastic and metal. I have a whole bunch of different things I could use to help me differentiate this. Okay, so I'm not sure where I'm going to put this. I take a look at this, I see that this has kind of a spoon shape. This kind of has a spoon shape. And this has kind of a spoon shape. Right? So maybe I can group all those together as well. This, oh, but I already have that. This bit here is massive. There's that little piece of paper. It's the same piece of paper in both, so it's huge. And this bit here is much smaller, but the two of them are very similar, right? They're both bits. So, and they're also very similar to the nail. So I'm going to probably group those two together. There's another spoon shape kind of thing here. And this is a weird shape, and this knife is weird. So when you guys look at yours, I'm gonna grab this hammer. So when you look at the online, you'll notice that the hammer, if you guys don't know a hammer, it has two little prongs here as well. So those two little prongs, maybe they match the two little prongs of this little corn cob holder, right? So now that I have all these things in groups, I can start figuring out what my evolutionary path might look like. So this nail is probably going to evolve into something that looks very similar to it. And I think this screw, which is a very similar size, could be one of those choices. This knife here, that also might be a choice. It's relatively straight. Remember, there's many different answers. I'm just giving you one interpretation. I don't normally do this in class because I find that if I say something, a lot of people typically just follow it and they don't think for themselves. I want you to think for yourselves. And plus, remember, I'm only using half the organisms. So this knife, maybe that represents another one of the events. So maybe there's a speciation event between these two, right? So my nail is my ancestor, and then undergoes a speciation event. I get to that screw, and I get to this butter knife. Right. Now from this screw, maybe it just got bigger, right? So it just got huge. So it went from small to like really big. This knife, maybe it underwent some kind of adaptation that caused it to change its shape. So instead of having that flat blade, it went to maybe this kind of spoon-like attachment, or maybe it evolved two prongs. Like I don't know, right? I just have to kind of justify this to the best of my ability, but this is a possibility, right? So that's what I'm going to say. I'm going to try to justify that. I'm going to try to talk about some environmental pressure, that maybe that the spoon went into an environment where it needed to pick up some water or liquid, and so the spoon was perfect. Or the knife went into an environment where it needed to spear fish or spear food, and so having two little knife attachments was perfect. I could have just as easily taken this and put it over here, where it went from 1 to 2. All right, so next, the spoon, I might say that it evolved into this big giant spoon. Look at that, look at the size of that. It's huge, right? Possibility. And I might say that this double prong thing evolved into this hammer, right? Because it also has two prongs and has plastic. That's all metal and it's all metal. So that, to me, it makes sense that that could happen. Okay. So I still have some other organisms over here to play with. So maybe this, on the way to going to this big giant screw, maybe along the way, it adapted and it formed this other long attachment. And this long attachment has a plastic piece here and it's like a giant syringe. It's a turkey baster, but maybe that happened. Maybe this went from a small little screw bit. Some environmental pressure caused it to get really large so it can make bigger holes, or to adapt so it can suck up water. It's a pretty big leap. Would that be punctuated if I went from here, or gradualism? This is kind of like gradualism. This here would definitely be punctuated because of the major changes that happen in a short period of time. Gradual changes in a long period of time. So this turkey baster, it's got some plastic. So now I'm kind of left with these. So there's a bunch of places where I could put this. Maybe this thing here became so specialized that it became, so this baster here, maybe that shape, that thing, make it bigger so you can see, maybe this end here, maybe that became specialized so that it can mix more effectively producing this shape, which is perfect for its environment. And now I have these. So what am I going to do with these? Well, how am I going to think? So here I had this spoon, and I said that it went to a big spoon. Okay, that's a possibility. But maybe there's a speciation event, and instead of just going to a big giant scoop, maybe it also transformed into this kind of this plastic piece here. Right? So it's okay to make changes, right? It's only the final product I'm going to look at. And then this plastic spoon here, it might have adapted. Oops. It might have adapted into this very specialized. And then I'm trying to extend my page here. Let me extend my page so everything's squashed on my page here. And then maybe this adapted into let me fit it here. All right. So let me draw my lines in. Right, so that's Oda here. This I'm saying might have evolved into this. This spoon might have had a speciation event. Here or here. It's hard to do this properly because I'm really pressed for room here. I'll let me extend the page now. There we go. All right. What? Okay, this thing will not cooperate. Maybe put a text box down here. And then maybe it'll let me drag it down. Okay, well, I can't really draw the lines I want to. It's just not cooperating with me here. But this spoon, maybe it evolved into this big scoop, and then maybe it evolved into this spoon. And then maybe this plastic spoon evolved into this spoon, and then maybe, well, it's an egg separator, and then maybe that evolved into this particular whisk-like attachment. Maybe this screw had a speciation event, went to a baster, and that big giant bit, and maybe this evolved into here. So now when I take a look at this, if I ask for convergent evolution, see how this and this look very similar, but they came from different evolutionary paths? So that would be a sign of convergent evolution. They have a similar morphology, but a different evolutionary history. Okay? So this is just one way of working your way through the activity. So notice I didn't use the shared derived characteristic table, and I didn't use the observation table, but you could have easily have used that. It's a very effective and efficient way. It's a very organized way of answering these kind of questions. So here is an example of a person taking all the different organisms and looking at them, observing them. And then once you've gone through all these observations, using that to build a shared derived characteristic table, which I don't have on here. It's a lot of work. I wouldn't necessarily say you need to do that. And then from there, it took that information and came to this. So this is just one example. This is one hypothesis of how it might work. The ancestral nail, and it goes to this or this. This then evolves into, I know it's hard to see, into this. And then this had a speciation event. So notice that sometimes there might be just a single gradual change. Sometimes it might be a speciation event, and it might go 2 different routes, right? It doesn't have to go 2. It could just go 1. It doesn't go 3 though. It's always a speciation event of 2. That's what we're using, okay? And then in the activity, I've mentioned about adding extinct organisms and adding your rebop, and those are all very exemplary, high-order thinking additions to this activity. So hopefully you can make it to at least this. You shouldn't be copying this. This is just one hypothesis. If all you do is copy this, then you don't even bother doing it, because this doesn't make a lot of sense. You're coming up with your own hypothesis of how all these organisms relate to one another. Okay, so that's the phylogeny activity. Hopefully seeing that will help you make more sense of it. pick 3 branches and create a justification. So what you would do there is you'd work your way and you look at this branch and say, well, from organism A to organism B, it got larger so that it was better able to make bigger holes and capture food. Something like that, right? And then pick another branch. It could be any branch. It could be a branch. It could be a branch like this, and then a branch like this, and a branch like this, right? You get to choose whatever branch you want, okay? And then another question was demonstrate convergent. I talked about that. A speciation event and explain a rim. I think that's self-explanatory, but a speciation event might have occurred right here. And then the reproductive isolating mechanism that separated this from here might have been the shape, so they no longer had the right physical adaptation in order to allow them to produce new species. It might have been behavioral, it might have been genetic. There's a lot of different rims we talked about in this class. Extinct species, extant, micro and macroevolution. So microevolution, show me where basically it's just a change in genes allele frequencies, so they'd have to be very similar. Macroevolution is a speciation event typically. So looking to see your understanding of the terminology from evolution applied into diversity. You've discovered 2 new organisms. So you'll notice that this person here, they added the organisms, they just drew them on. I guess I'll use the color so you can see. They just drew them on. New organism, new organism. Is your phylogenetic tree more indicative of gradualism or punctuated equilibrium? I think that's self-explanatory. At the genetic level, why would, I'm not going to go over those ones. And that's it. So hopefully you have success. Hopefully this helps explain what the task is about in a little bit more, with a little bit better of an illustration. And if you have any questions, make sure you ask. Send me a quick message. I'm happy to meet with you in Google Meets and we can go over this concept together.